we're going to start some introduction to matrices. This is section 4.1. Let's get started. First, we're going to talk about what a matrix is. A matrix is a simple way of organizing data. It's just some brackets holding numbers together. That information can be done with an example of your desktop, which is a wallpaper, and you have a screen with pictures on it, and each one of there's little dots called pixels, and each one of those has a color in it. Those colors can be represented with numbers, and those numbers can be put inside a matrix. Each element tells what color to put as that spot. We can do different mathematical operations to have things move around on the screen also. That's just one example of a matrix. Here is what it looks like. We have these brackets with the numbers here. I want you to notice that it's rectangular. And we have letters or numbers inside representing different things depending on the problem itself. I want to have you notice there's no commas in here. They are nice columns and rows, and there's no need for a comma. Whenever we talk about these matrices, we're going to be talking about their dimension. And we have rows and columns. The rows go across. These are rows. We have 3 rows here. We also have some columns. We have 4 columns here. So if we're going to list the dimensions, we're going to list this one by the row first, the 3, and the column second. So this one is a 3 by 4 because we have 3 rows and 4 columns. All right, now let's talk about what it means to have equal matrices. In order for 2 matrices to be equal, they must have the same dimensions and they must have corresponding elements must be the exact same thing. So the one at the top up there are equal matrices. They're both 2 by 2s, and they have the exact same elements together. For example, the top left has the top left. The bottom right has the same bottom right. And each of the pieces are exactly the same. So over here on the side, if we have these 2 examples here, this one at the bottom, if we could find the variables knowing that they're equal. I'm telling you they are equal, so that means that this top left has to equal top left. So 12x has to equal 6, so x would have to be a half. Y would have to be 3, and 24z would have to be 24, and so we would know that z was 6. So we could set the corresponding pieces equal to each other. If we're adding, now we're going to add and subtract. This is a very straightforward process. If we're going to be adding, we can only add them if they have the same dimensions. So these 2 here are a 2 by 2. This one's a 2 by 2 because we have 2 rows and 2 columns. Same with this one. We have 2 rows and 2 columns. So we have a 2 by 2. Since it has the same dimension, they are able to be added. So to be able to add them, what we do is we just add their corresponding elements. So if I want to do that, this one's going to be a 5 and a 6. I'm going to add them up to be 11. I'm going to have this 2 and 2, and it's going to add up to 4. We have the x and the 3. We can't put them together, but we could add them. X plus 3. And then we have the 9 and the y, and we can put those together. 9 plus y. And there would be our answer. Now we're going to do something called scalar multiplication. Scalar multiplication is just very similar to the distributive property. We just multiply that 2 to everything. There's never going to be a time when you can't do the scalar multiplication. There's nothing to do with dimensions like we had before. So if I'm going to multiply the 2, I'll multiply it to the 4, and I'll get 8. It'll be in the top left just like the 4 was. I'll multiply that 2 times the negative 9, and I'll get a negative 18, and it'll be in the top right like the negative 9 was. Then we'll multiply the 2 and the x to get 2x, and we'll put it in the place where the x was. We have the 2 times the 8, and we'll get 16, and we'll put it in the place that the 8 was. And here is our new one for our scalar multiplication. All right, let's do some together now. We're going to do numbers 1, 3, 5, 7, and 11. And we're going to do those first. Let's do number 1. Number 1, this is addition. And when I'm adding, we add the corresponding parts to 2 matrices that have equal dimensions. So let's check out the dimensions here. This is a 2 by 3. A 2 by 3, and this is a 1 by 4. They are not equal. We cannot add these. If you look on your instructions, it says that we write the word undefined. Let's do number 3. Number 3, this is a 4 by 1 and a 4 by 1. So these are equal, so we can multiply them, or excuse me, add them. All right, so we're going to add these 2 together, and we'll get 5. Just a second, I need to make this a little taller. We're going to have a 5. Add these together, and we're going to get a negative 12. Add these together, and we're going to get a positive 3. And add those together, and we're going to get a 5. So here will be our new matrix. It'll have the same dimensions as the others. Let's do number 5 here. This one is a 1 by 2, and this is also a 1 by 2, so they are equal. We can add them or subtract them. On subtraction, you need to be really careful. Be really careful when we're subtracting to make sure we have that subtract distributing. So we're going to have a 6 minus the y plus z. You can leave it this way, or you could distribute it and have a 6 minus y minus z there. But that subtraction goes to everything. The next one we have a z squared minus a 5y. And there is our new matrix. This one can be written also the z squared minus 5y. So we can write that answer. Just make sure you leave a space in there in between the two so we can see them. Let's do number 7. 7 is scalar multiplication. We're going to multiply those together. I'm going to have the same dimension as that when I'm done, so I'm going to just write a tall one here. If you remember scalar multiplication, I just multiplied this to everything. So I'm going to have the 2 times the 2 there, which is 4. A 2 times the negative 3, which is negative 6. A 2 times 0, which is 0. And a 2 times the negative 1, which gives us negative 2. Last, another scalar multiplication. Now we have some variables in there. We're going to have a 3 by 2. So I'm going to make sure I make my answer be big enough here to fit it all. And we're going to just multiply that 2 to everything. I'll have 2n. We'll have 2m. We'll have 8mp. We have 2 times 5, we have a 10. We have a negative 6m. And we have there, we can distribute that or leave it. We could leave it 2p plus 3. Or we could distribute that and have it at 2p plus 6. That's your choice. Okay? All right. Let's do this one. I've got the instructions up here. Solve the equation. Notice that the variable is capital. That means that it's a matrix. So right in here, this x that we're looking for is a capital X. So we're looking for a matrix. We're asking, we have a matrix, and if we multiply 4 by that we have a matrix, and it's 4 times this one. So what was the original matrix? So we're actually going to divide by a negative 4. So if negative 32 divided by 4 would be 4. Excuse me, 8. And negative 32 divided by that negative 4 is going to be another 8. So our original matrix times the negative 4 would have given us this one. Okay? Let's do the next one. We're asking here, some matrix added to the negative 7, negative 1, 4, 1 will equal this one. What is that matrix? If you remember, they had to be equal in dimension. This is a 2 by 2, and we got a 2 by 2. So this y was going to have to be a 2 by 2. So I'm going to draw a place for my 2 by 2. And that means that that's y. And this top left plus the negative 7 is going to give us a negative 2. We could just subtract. We could just, since we're adding, we're trying to find that out. We could just think about what it's going to be, or we can do some kind of algebra. For example, I have negative 2 equals that y minus 7. I could just move that to the other side by subtracting the negative 7 or adding 7, which is going to be a 5. We can do the same thing. We can subtract the negative 1 or add the 1 over to there. And I'm going to get negative 11. For this one, we're going to subtract the 4 over to here. So I'm going to get negative 4. And then we're going to subtract the 1 over here and get a 3. So the check could be, I'd ask myself, does this number right here, the 5, added to negative 7, does that truly give us that? Yes, it does. And we could check that for all of them. All right, let's talk about matrices on the calculator. Everything we do by hand, we will do on our calculator. The test will be in 2 parts. There'll be a by hand part without your calculator and a graphing calculator part. Each part will be on a separate printout. You may want to get a head start at looking at your calculator by just experimenting. There's a matrix button there on your calculator. Maybe you can figure out how to do these on your calculator. I will spend some time in class showing you, but you're going to actually remember this better if you figure it out yourself. All right, this time in this lesson, we learned what a matrix was. We learned its dimensions. If you remember, the dimensions were its rows times rows, and then we put an X, rows by columns. We learned how to determine if they were equal. They're equal if they have the same dimensions and the exact same things in each of the corresponding pieces. We learned how to add and subtract them. Remember, they have to have the same dimensions to be able to be added. And we learned the scalar multiplication, which is very similar to the distributive property. We're now finished with this. Goodbye.